add, find the equation of the line. You want to put it in slope-intercept form. So find the equation of the line in slope-intercept form that contains the point -2, 5, and let's say 4, -2, something like this. Oops. All right, so find the equation of the line, and you'll write it in slope-intercept form that contains that point. Okay, so one of the things I asked you to do is to look at the video from the last class period. So how are you going to do this? It's on test 3, and it's on your final. What are you going to do? All right, so the idea, in order to write the equation of a line, you're going to use point slope form. All right, so point slope form is y minus y1 equals the slope times x minus x1. And in order to use that form, remember this is called point slope form. In order to use that form, you need to know the slope and a point on the line. All right, so I know a point on the line. What is it I don't know? The slope. So you got to first of all find the slope. So we can use the slope formula. So you must find the slope. So the slope formula is y2 minus y1 over x2 minus x1. Okay, and let's just go ahead and label this x1, y1, and this x2, y2. And remember, the order does matter when you put your numbers into these letters, these variables. So what's y2 in this case? Subtract y1, which is 5, divided by, since I started y2, I must start with x2. And what's x2? 4, subtract x1, which is -2. What's the numerator? What's the denominator? 6. So my slope is -7, 6. So if I were to graph this line that I'm interested in, would the line rise or fall? It will fall because the slope is negative. Okay, so once you know the slope, then it's just a matter of you plugging information into this point slope form. Does it matter which of these points I use? No, it does not matter. All right, so let's go ahead and use the first one. So remember, when you plug one of these points back into your formula, always plug it back into y1, x1, never x and y. So it must be x1, y1 that you substitute numbers into. So I'm going to get y minus y1. What's y1? 5. We're using this equals a slope which is -7, 6 times x minus x1, which is a -2. That's a -2. All right, now go ahead and rewrite this. We talked about that. Rewrite this. So don't leave it as x minus a -2. This is really x what? Plus 2. So it's y minus 5 equals -7, 6 times x plus 2. All right, now what form is this right here? No. What form is this? Point slope form. That's point slope form. That's this right here, right? Okay, now the directions ask you to write this in slope-intercept form. So what letter must I get by itself? Y. So go ahead and distribute. So I get y minus 5 equals -7, 6 times x, -7, 6x. A -7, 6 times a +2. Okay, -14 over 6, but you could have reduced first, right? Okay, but reduce this then. If you didn't reduce at the beginning, you got to reduce now. So -7 over 3. So that's -7 over 3. That's what I have at this point. All right, and then one more step and you're almost done. What's the next step? Add 5 to both sides. Combine like terms, that's 0. So you get y equals negative 7/6x. Now use your calculator for this. Your calculator, you're going to say negative 7/3 plus 5. So negative 7/3. So negative 7/3. Let's see this. Probably not, but negative 7/3 plus 5 equals, and you get this decimal. Now, most of you already know that 0.666 is what fraction? 2/3. So this is 2 2/3, right? This right here is 2 2/3. What is that as an improper fraction? 8/3. 3 times 2 plus 2, right? Okay, if you didn't know that, then on your calculator you would press. You would go to that second function right here, then press this right here, and then you see this, and then press enter, and it writes it as 2 2/3. So it gives it as a mixed number, but then you need to rewrite it back as an improper fraction. All right, so then your answer would be y equals negative 7/6x plus 8/3. Okay, so that's the equation of that line. Whatever that line looks like, when that would be the equation. Now, if you had used the other point, would you still get the same answer for the slope-intercept form? Yes, you will. Okay, and then the other thing you need to be able to do for test 3 is this. All right, find the equation of the line. All right, find the equation of the line. And you want to write it in slope-intercept form. That contains the point negative 4, 5 and is perpendicular to the line, whose equation is y equals negative 2/3 x plus 6. So we're going to find the equation of the line that goes through this point, but is perpendicular to this line. All right, you still need to use point-slope form. In both of those cases, you have to use point-slope form. Okay, what's point-slope form? Okay. In order to use this, you got to know two things. What two things must you know? A point on the line and the slope. Do I know a point on the line that I'm interested in? Yeah. Yep, right here. So that's your x1 and that's your y1. Do I know the slope of that? Does it come out and tell you what the slope of that line is that I'm interested in? No. But what do you know about that line right here? It's perpendicular to this line. So what's the slope of this line right here that I'm pointing to? Negative 2/3. So the slope of this line is negative 2/3, which means the slope of the line I'm interested in then is going to be what? What do you remember about perpendicular lines, about their slopes? They're negative reciprocals. Parallel lines have the same slope. Parallel lines have the same slope. They have the same tilt. Perpendicular lines intersect at right angles. So you'll notice that one will be increasing, the other will be decreasing. So one's positive, the other's negative, and they are negative reciprocals of each other. So if the slope of this line here is negative 2/3, then what's the slope of this line that I'm interested in? Not 2/3, 3/2. The negative reciprocal. The reciprocal of 2/3 is not 2/3. The reciprocal of 2/3 is 3/2. and that's what you plug in here. So I get y minus 5 equals the slope, which is 3/2, times x minus a negative 4. So the slope here you had to get from this line that's perpendicular to it. All right, now you need to go ahead and rewrite x minus negative 4 is x plus 4. You have to do that. So that becomes x plus 4. And now, remember, this is now point slope form right here. Okay, now you want to write it in what form? Slope intercept. So let's distribute first. So y minus 5 equals 3/2 x plus, all right, what's 3/2 times 4 over 1? 3/2 times 4 over 1. 12 over 2, which is just what? 6. It's just 6. So that's just 6 right here. Now what's the last step? Add 5 to both sides. And what's my answer to slope intercept form? Yep. Okay. Right. So if you were to graph, and they're not asking you to graph this, but if you were, you kind of get an idea of what's going on here. So we have to graph two lines just to show you. So this line right here, what's the slope of this line? All right, and remember, one of the worksheets, or one of the things that you have to be able to do is graph a line using the slope and the y-intercept. What's the y-intercept here? 6. So I'm going to graph the y, I'm going to plot the y-intercept. So the y-intercept is 6. And then from that y-intercept, I'm going to use the slope. Remember that? The slope is what? So, and it's rise over run. So what's my rise here? Okay, so since the rise is negative, that means I do what? Go down 2. What's my run? Positive 3, which means I go to the right 3. Okay, so from the y-intercept, I'm going to go down 2, 1, 2, and then to the right 3, 1, 2, 3. So there's that line, that other line. Okay, remember this is the line y equals negative 2/3 x plus 6. That's that line. But that's not the line I'm interested in, because they already tell you what the equation is. I want to know the equation with a line that's perpendicular to this and goes through what point? Negative 4, 5. So here's negative 4, 5 right here. Okay, that's negative 4, 5. I want to know the equation of the line that goes to that point. And it's perpendicular to this, right? All right, so what I just found is that whatever, I'm not going to draw it just yet. Now you could. You just got to make sure that if you draw it, it forms what kind of angle around here? A right angle. Does this right here look like a right angle? No. See how it does this? Is that a right angle? No. So you got to draw it in such a way to where it looks like it's a right angle, right? I don't know. So maybe like this, maybe somewhere around here. Okay, but I'm not going to draw it just yet. I'm going to use the equation we just found. So the equation we just found was y equals 3/2 x plus, what was it? Plus 11. So this right here says that my y-intercept is what? Okay, that's this. So now I can draw it. So you kind of, this is it right here. Let me extend this. Okay, I can draw this now. You'll see that this is the line now. So this is what kind of angle right here? Right angle. So what you found is that this equation is y equals 3/2 x plus 11. So that's the one I was interested in. So if you compare this with what the word said, it says find the equation of this line that goes to this point and is perpendicular to what? That line. So that's what the graph looks like. Okay, so the equation that line just found is this. All right. So we talked about that on that day when most of you didn't show up. Now, I'm going to pass towards the end of the period, I'm going to pass an attendance sheet for that day. Remember, to get credit for that class period on Thursday, what did you have to do? From when? From that Wednesday. Okay? And so I'm assuming you're going to be honest with this. Okay. So if you didn't watch it, don't sign the attendance sheet. Okay, so make sure you're aware that this is test 2 is Tuesday, and this is your study guide. Hopefully you've been looking at this. You've been going through all those worksheets and redo them over and over. Okay? One of the things you have to be able to do on test 3 as well. We're talking about test 3 still, not test 2. But this is test 3. Is if you want to graph f of x equal 3x minus 1 if x is greater than 4, x plus 2 if x is less than or equal to 4. So what kind of function is this? What do they call these functions? Piecewise. So you got to know your terminology. So I don't know if all of you knew that. I know some of you did because you said it. These are piecewise functions. So you're going to graph them. I don't even know how to spell the word piece. Piecewise. Piecewise functions. All right, so you're going to graph them in pieces, right? They look like parts of a graph. So you're going to graph each one individually, correct? So first of all, we're going to graph the top one. And all that's in those videos, all that's in the class notes that I posted. And what's the domain for this one right here? What domain must I use? Remember, the domain is your x values. What x values must I use for this graph? You got to tell me x is greater than 4. I got to use any number bigger than 4. So my domain will be x is greater than 4. So we talked about the fact that when I do my t-table, and this function right here is the linear function, right? All right, but when you graph it, it's not going to be a line. It's going to be a what? A ray. Very good. It's going to be a ray, not a line. And to graph a line or a ray, you're going to need 2 points. Now, what must one of these x values be? You must use this number that shows up here, 4. You got to use 4. And if x is 4, you just plug it back into your function. So I get 3 times 4 minus 1. That's 12 minus 1, which is 11, right? Now, when I plot that point, though, am I going to plot it as a closed circle or an open circle? Very good, because this has no equal sign. So it's going to be an open circle. And I need one more number for x. So you got to pick a number that's in here, though. 5, okay? You can't pick anything less than 4. It's got to be bigger than 4. So this time I'm going to get 3 times 5 minus 1. So y is going to equal 15 minus 1, which is 14. All right, and so and then in a little while we're gonna graph this right. Now let's do the next one. So the next one says I got to graph f of x equals x plus 2 if x is what? That's equal to 4. So again, that's going to be an array because my domain's restricted. So that's going to be an array. I have to start with what number for x? So whatever number appears here. So when x is 4, I get y equals 4 plus 2, which is 6. Give me another number that's less than this. 0. Okay, when x is 0, I get y equals 0 plus 2, which is 2. Now at 4, 6, is that going to be an open or closed circle? It will be closed because of the equal sign. And then you just graph it and you're done. Just make sure that they're rays that you're drawing and not lines. So the First one is 411. So 411 is here, right? That's an open circle, correct? So make sure it's an open circle you put there. And then the other point is 514. So let's say 514 is here. 514. I put a dot there. And then I draw my ray. I got to start with this point, right? So there's part of your graph. So don't draw a line. Don't extend this coming down like this and put an arrow on both ends. That's incorrect. Because this says that I can only use what x values greater than 4. Not less than 4, greater than 4. All right, and then the other ray, okay, 4, 6 is here. Is that open or closed? And then the other point, 0, 2. All right, and then I just draw my ray, starting here, going down. And there's your graph. All right. Okay, so that was something we talked about last week, I think, sometime. All right. Okay, now let's talk about quadratic functions. So this is new. One of the things you picked up, one of the stuff you picked up should have been where they talked about graphing quadratic functions. So there's something called standard form and there's something called journal form. Did y'all pick that up? Okay, go ahead and get that ready.